certain results which follow on the AM-GM-HM inequality for n numbers. Among that, the first one says that if the sum of n distinct positive numbers, if the sum of n distinct positive numbers is given to be a constant, say k. So if the sum of n distinct positive numbers is given to be a constant, say k, then their product is maximum when is their product maximum? If their sum is given to be constant, then their product is maximum when all these numbers are equal and equal to n by k. Are you understanding? And equal to n by k. So over here, if you can see, what have I basically done is, I am saying that if the sum of n distinct positive numbers is given to be a constant k, then their product is maximum when all these numbers are equal and equal to k by n. And they are equal to k by n, constant upon the number of terms. That means the sum of n terms, which is a constant upon the number of terms. That's what I am talking about. Each number out of these n numbers will be equal to k upon n. Only then can I say that their sum. See, when you're going to add these n numbers, if they are equal to k upon n each, let's go backwards. If I have n numbers with me, each one of them is equal to k upon n. When you add them, you get n times k upon n, which is k. So you get the sum of these n numbers to be equal to k, and in that case, their product which you are going to find, which is n, which is k upon n into k upon n into k upon n, n times. When you're going to find the product, you will be having the maximum product of these n numbers, when all of them are equal to k upon n. So, for understanding, suppose I am saying I have A1, A2, A3 and so on up till A10, positive numbers which are all distinct. Then in that case, what about the AM-GM-HM inequality for these 10 positive distinct numbers? It will be A1 plus A2 plus A3 plus and so on plus A10 whole upon 10 is equal to A1 into A2 and so on into A10 whole to the power 1 by 10. Right? Now, if A1 plus A2 plus A3 up till A10 is given to be a constant k, in that case this inequality, because AM is greater than or equal to GM, AM of 10 numbers is greater than or equal to GM of those same 10 numbers. In that case, if this is equals k, you are going to have k upon 10 is greater than or equal to A1, A2 up till A10 whole to the power 1 by 10. Raise to the power 10 both sides, what you obtain is k upon 10 whole to the power 10 is greater than or equal to A1, A2 and so on up till A10, or you can say A1 into A2 into A3 into A10 is less than or equal to k upon 10 whole to the power 10. That means the maximum value of this product is this particular expression. Maximum value of the product of these 10 distinct positive numbers is this. And when is this maximum value attained? Attained when you have taken AMGM of these n numbers, 10 numbers, when all these 10 numbers are equal. When A1 is equal to A2 is equal to A3 and so on is equal to A10. Then A1 plus A2 plus A3 plus and so on plus A10 is equals to K gets converted to what? A1 is equals to A2 is equals to A3 is equals to A10. So let me replace everything by A1 because all of them are equal to A1. So I am going to get A1 plus A1 plus A1 plus A1 equals K, and this is going to be added to itself 10 times because there are 10 distinct numbers and A1 is being added to itself 10 times. So this will be 10 times A1 equals K, or A1 is equal to K upon 10. Similarly, if A1 is K upon 10, A2 is K upon 10, A3 is K upon 10, A4 is K upon 10 and so on, A10 is K upon 10, only then you can have K upon 10 plus K upon 10 plus K upon 10 times, that is 10 times K upon 10 is going to give you K. So A1 is K upon 10, which is equal to A2, which is equal to A3 and so on, which is equal to A10. And therefore, if you have, whenever you have n distinct numbers with you which are all positive, such that their sum is given to be a constant, in that case their product is maximum only when all these n distinct terms are equal and equal to K upon n. N is the number of terms and K is the constant which is equal to the sum of these n distinct positive terms. Fine. That's all about the first result. Let's look at the second result. Okay. So the second result is somewhat similar to the first result only. What does it say? Let's see. It says if the product of n distinct terms, if the product of n distinct terms which are positive if the product of n distinct positive terms is given to be a constant, if that's given to be a constant, say K, then their sum is minimum, then their sum is minimum when all these n numbers are equal. The first question says that if the non-zero numbers 3 given are there, x, y and z, they are in AP, and tan inverse x, tan inverse y, tan inverse z is also in AP, then what is the relationship between these three numbers? So if x, y and z are in AP, that means twice of y is equal to x plus z. And if tan inverse x, tan inverse y and tan inverse z are also in AP, that means again that twice of tan inverse y is equal to tan inverse x plus tan inverse z. right? Twice of tan inverse y means tan inverse 2y upon 1 minus y square, right? Tan inverse x plus tan inverse z means tan inverse of x plus z upon 1 minus xz. If these two things are equal, that means their arguments are same. 2y upon 1 minus y square equals x plus z upon 1 minus xz. Now 2y is equal to x plus z, the numerators are equal, so automatically for these fractions to be the same, 1 minus y square equals 1 minus xz. This eventually means y square equals xz. So x, y, z are in AP, from here you can say x, y, z are in GP. So if three numbers are in AP as well as GP, then that only means that they three are equal. So we began with these three terms being in AP. Because of the second very argument given to us, we concluded that they are in GP as well, and therefore all these three numbers have to be same. Only then can they be in both AP as well as in GP. So that's how we deal with this question. Let's move on to the next one. Second question says that if three positive real numbers are in AP such that their product is 4, then what is the minimum value of B? Okay, so if A, B, C are in AP, that means B minus A is the common difference D, and that is same as C minus B. This means what? This means that A is B minus D, and it means that C is D plus B. Now if A into B into C is given to me as 4, what is A into B into C? A is B minus D, B is B, and C is B plus D. This is 4. This means B into B square minus D square is 4. Now, you know that B square minus D square is obviously less than B square. You can just take it strictly less as well. Fine. So B into this is less than B into this. So you get B into B square minus D square is less than B cube. But B into B square minus D square is actually 4. So 4 is less than B cube, or B is greater than 2 to the power 2 by 3. If B is greater than 2 to the power 2 by 3, that means minimum value is this. You can take it to be equal to, and then you are going to get it to be the minimum value. What is the minimum value? 2 to the power 2 by 3. Now the next question says what? That if B minus C, 2B minus X and B minus A are in HP, harmonic progression, then A minus X by 2, B minus X by 2, C minus X by 2 are in what? So if these three terms are in HP, that means their reciprocals are in AP. So if the reciprocals are in AP, that means 1 upon B minus C, 1 upon 2B minus X, and 1 upon B minus A, they are in AP. This eventually means twice of the middle one. Twice of the middle term is equal to sum of the first and the third. So 1 upon B minus C plus 1 upon B minus A. Very, very easily you can resolve this expression completely, and what you are going to get is B minus X by 2 whole square is equal to A minus X by 2 into C minus X by 2. Which means that what? B minus X by 2 whole square equals A minus X by 2 into C minus X by 2 means that A minus X by 2, B minus X by 2, C minus X by 2, they are in GP. So if these three terms are in HP, their reciprocals are in AP, because of which this is the relationship between them. Resolve it, you get this, which means A minus X by 2, C minus X by 2, B minus X by 2, they are in GP. Moving to the next question. If the first two terms of a harmonic progression are given to you as 2 by 5 and 12 by 23. So if they are given to you as 2 by 5 and 12 by 23, then the largest term is what in this HP? So the first two terms, first term of an HP is 1 by A, second term is 1 upon A plus D, because their reciprocals are in AP, right? 1 upon A is given to you as 2 by 5, 1 upon A plus D is given to you as 12 by 23. From here you can say A is 5 by 2, and again from here you can resolve and you can get D is minus 7 by 12. Nth term of the HP is given by what? 1 upon A plus N minus 1 into D. You have A, you have D, you are going to find this out. This is going to come out to be 12 upon 37 minus 7N. I want that N for which I can get the largest term. Now you can see if you put N equals 1, you get 12 upon 37 minus 7. See, one thing you understand, for this complete fraction to be the largest, the denominator has to be the least. This is going to be largest when the denominator is the least. For which N the denominator is the least, you can very clearly see, you can plug in N equals 1, 2, 3, 4, 5. At 5 you will have to stop because 6 is going to exceed it again. At 5 if you stop, you get 37 minus 35, which is 2. That is the least denominator you can get, for which you are going to get the largest value of this fraction, because if you move ahead of it, you are going to get negative in the denominator, which eventually is going to make the entire fraction negative, which is going to make it smaller in magnitude, right? So that is why for this complete fraction to be the largest, the smallest positive quantity which this denominator can gain is 2. That is when this difference is 2, that means when this is 35, which means when this is 5. So for N equals 5, that means for N equals 5 I am getting this term becoming the largest. So fifth term of this harmonic progression is the largest. Answer is option number A. Okay. What is the next question? Let's see if 3 arithmetic means, 3 geometric means and 3 harmonic means are inserted between 1 and 5. Okay. Then find the cubic equation whose roots are first AM, second GM and third HM between 1 and 5. So see, situation is, this is 1, this is 5, A1, A2, A3. 3 arithmetic means are inserted. I am only interested in the value of first arithmetic mean, which is what? It is A plus D, where D is B minus A upon N plus 1. So what is A1? A is 1, see, this is A and this is B. So 1 plus B minus A, 5 minus 1, that is 4 upon N is 3, 3 plus 1 is 4, you get 2. So 2 is the first arithmetic mean. Again, if you have 3 geometric means inserted between 1 and 5, what is the value of the second geometric mean? It is AR square, where R is B upon A to the power 1 by N plus 1. So A is 1, R is B by A, that is 5 by 1, square to the power 1 by N plus 1. So 1 upon 3 plus 1 is 1 upon 4 into 2, so 2 upon 4. This is root 5. And similarly, if between 1 and 5, you have 3 harmonic means inserted. If between 1 and 5 you have 3 harmonic means inserted, I am only interested in the value of the third harmonic mean. I know that 1 upon H3 is 1 upon A plus 3D, where D is A minus B upon N plus 1 into AB. And therefore 1 upon H3 comes out to be 1 upon 1, because A is 1 plus 3 times A minus B, 1 minus 5 whole upon N plus 1 into AB. So you get 1 minus 3 by 5, that is 2 by 5. So H3 is 5 by 2. That's how you get the first arithmetic mean, second geometric mean and third harmonic mean. These 3 are the roots of a certain equation, cubic equation. And when you know all the roots of this cubic equation, you can get the cubic equation, isn't it? The 3 roots are what? Suppose I am saying the first root is what we got, 2, second was root 5 and third was 5 by 2. What is that cubic equation? It is x cube minus sum of the roots, into x square plus sum of product of roots taken 2 at a time. So 2 into root 5 plus root 5 into 5 by 2 plus 5 by 2 into 2 into x minus product. So it is 5 root 5, that's the constant term. X cube minus sum of the roots into x square plus sum of product of roots taken 2 at a time into x minus product of the roots. And this is what, if you resolve, you get the first option as the correct one. Clear? First question is, if log 2, log of 2 to the power x minus 1 and log of 2 to the power x plus 3 are in AP, then what is the value of x? The very fact that these three terms are in AP means that twice of log of 2 to the power x minus 1 is equal to log 2 plus log of 2x plus 3. Right. So from here you get log of 2 to the power x minus 1 whole square equals log of 2 into 2 to the power x plus 3. You know log to the base e is a 1 function, so this implies 2 to the power x minus 1 whole square equals 2 into 2 to the power x plus 3, which means 2 to the power x whole square, which is 2 to the power 2x plus 1 minus 2 into 2 to the power x equals 2 into 2 to the power x plus 6. So what are you left with is 2 to the power 2x minus 2 into 2 to the power x minus 2 into 2 to the power x, which is minus 4 into 2 to the power x plus 1 minus 6, which is minus 5. Okay? So from here, when you basically break the middle term, you get 2 to the power x minus 5 into 2 to the power x plus 1 equals 0. Now I know that this can never be possible, that this is equal to 0. Why? Because 2 to the power x is never negative. So if this is equal to 0, you basically get, what do you get? 2 to the power x equals minus 1, which is wrong. And therefore for this expression to be 0, 2 to the power x will have to be equal to 5, or x will be log 5 to the base 2. And therefore the value of x is log 5 to the base 2 for these three terms to be in arithmetic progression. Next question says what? It says that a, b, c are in AP and a square, b square, c square are in HP. If a, b, c follow what? So a, b, c are in AP means that twice of b equals a plus c, and a square, b square, c square are in HP means that b square equals twice of a square, c square upon a square plus c square. Clear? Now it says that if they are in HP, then what is the condition between A, B, C which they are going to follow? So understand, over here if I just eliminate B, because B is A plus C by 2, I plug it in over here, I get A plus C by 2 whole square equals 2A square C square upon A square plus C square. So from here what do you get is A square plus C square plus 2AC equals 8a square c square upon a square plus c square. So this eventually gives you what? Let's see. This gives you a square plus c square whole square plus 2ac minus 8 a square c square equals 0. So you basically land yourself to the step a plus c whole square plus 2ac multiplied by a minus c whole square equals 0. So either this is 0 or this is 0. Only then this product can be 0. So if a minus c whole square is 0, this means a minus c is 0, which means a equals c. But if a is equal to c, you get 2b equals to a, which means b equals a. So eventually you will get a equals b equals c. So this expression is 0, or this and this, both of them are going to hold simultaneously if a equals b equals c. This is one very condition in which they are going to hold. Another condition is that if this is 0, that means a plus c whole square plus 2ac is 0. Now a plus c is twice of b, so you basically get twice of b whole square equals minus 2ac, right? Which means b square equals minus 1 by 2ac. I can write this as minus 1 by 2a into c, or I can write this as a into minus 1 by 2c. B square equals minus 1 by 2a into c means minus 1 by 2a, b and c are in GP, and b square equals a into minus 1 by 2c means a, b and minus 1 by 2c are in GP. So either this holds or this holds. Even then in that situation this particular product will be 0, and hence both these facts of AP and HP are going to hold simultaneously. That means when AB and minus half C and minus half ABC are in GP, these are the three conditions, the three very situations where ABC will be in AP and A square, B square, C square will be in HP. Next question says what? That ABC are real numbers and ABC are in AP. Match the expression in column 1 with the properties or conditions in column 2. Let's see how do we need to tackle with this question. So ABC are already given in AP, that means you already have that twice of B equals A plus C. A square, B square, C square are also in AP, that means twice of B square equals A square plus C square. This is already given to you. Fine. Now A plus C whole square is what? A plus C whole square is 2B whole square, right? What is 4B square? It is twice of 2B square, but 2B square is A square plus C square, so this is 2A square plus 2C square. This is A plus C whole square, which is A square plus C square plus twice of AC. Now 2A square minus A square is A square, 2C square minus C square is C square, minus 2AC gives you A minus C whole square is 0, which means A equals C. If A comes out to be equal to C, again B comes out to be equal to A, comes out to be equal to C. So you basically get A equals B equals C. So the first point gets matched to P. So corresponding to A, you basically shade P. Clear? Next you have A square, B square, C square are in GP. Okay, so A, B, C continue to be in AP. It's given that A square, B square, C square are in GP. That means B square whole square equals A square, C square, or B square can be written as plus minus AC. Now if B square equals AC, this means A, B, C are in GP. And if ABC come out to be in GP, ABC are already given in AP, that means again A equals B equals C. So ABC are coming out to be in GP, they are already given to be in AP, and therefore A equals B equals C. So corresponding to B also, option P is what comes out to be correct. Third we have A square, B square, C square are in HP. Let's see. A square, B square, C square are in HP, that means B square equals twice of A square, C square upon A square plus C square, right? Again, because they are given in AP, exact same argument like we did in the previous question. Here also again, B will be replaced by A plus C by 2. And this is how the expression is going to just be in terms of A and C. Fine. Now when you simplify, you get A plus C whole square plus 2AC multiplied by A minus C whole square equals 0. Again you get either A equals C, which eventually would mean A equals B equals C, or you are going to get that if this is equals to 0 means what? A plus C will be replaced by 2B. So you are basically going to get from here, if this is equal to 0 means that A or minus 1 by 2A, B and C are in GP, or A, B minus 1 by 2C are in GP, and from here you are going to get that A equals B equals C. So corresponding to option number C, P, Q, R, all three are going to be shaded. P also, Q also, and R also. Fine. Then you have D, that is A plus B plus C is 3 by 2. Then what among those are going to hold? So if A plus B plus C is 3 by 2, so you have A plus B plus C is 3 by 2. You already know A plus C is twice of B. If A plus C is twice of B plus B is 3 by 2. Thrice of B is 3 by 2, B is 1 by 2. So D is basically going to be shaded to S. Fine. Moving on to the next question we have, suppose 4 distinct positive numbers. So suppose 4 distinct positive numbers A1, A2, A3, A4 are in GP. If that is the situation, I am going to say let the first term of that GP be small a and the common ratio be small r. So you get A1 is A, A2 is AR, A3 is AR square and A4 is AR cube. B1 is A1, so B1 is A. B2 is B1 plus A2, B1 is A and A2 is AR, so A plus AR, which is A1 plus R. B3 is what? B3 is B2 plus A3, B2 plus A3, B2 is B1 plus A2, B1 is A plus A2. What is it? A, B1 is A plus A2, so we've already written that. B3 is B2 plus A3, that means A1 plus R plus AR square, which means A common 1 plus R plus R square, and similarly you get B4 as A common 1 plus R square plus R cube. Statement 1 says that B1, B2, B3, B4 are neither in AP nor in GP. Let's check. If I talk about AP, what is B2 minus B1? B2 minus B1 is A plus AR minus A, which is AR. What is B3 minus B2? B3 is A plus AR square minus A minus AR, so you have AR square, and these two are not equal. So yes, B1, B2, B3, B4 are not in AP. But are they not in GP also? Let's check that they are in GP or not. So if I talk about B2 by B1, B2 is A 1 plus R, B1 is A, so you are just left with 1 plus R, and B3 by B2, B3 is A 1 plus R square, and here you have A 1 plus R, so you can very clearly see that both of them are again not coming out to be equal, so they are not in GP as well. And therefore statement 1 is true that they are neither in AP nor in GP. Are they in HP? Are they in HP or not? So for HP, what do you check basically? What do you check for HP? That the reciprocals should be in AP. So B1, B2, B3, B4 are in HP or not? That means 1 by B1, 1 by B2, 1 by B3, 1 by B4 are in AP or not? So for that, 1 by B2 minus 1 by B1, if it comes out to be equal to 1 by B3 minus 1 by B2, that means yes, they are in AP, but you are going to find they are not going to come out to be equal, in which case the reciprocals are not coming out to be in AP, so the terms will not be in HP. So these terms are in HP, this is false and this is true. Statement 1 is true and statement 2 is false. Clear?